Hi guys, welcome to today's tutorial. Today we'll be looking at possible JUPEB mathematics questions most likely to be out in your forthcoming exam. Now, our first question is given that set A is minus 5, minus 3, minus 1, 0, 1, 2, 3, and our set B is minus 4, minus 3, 0, 3, 5, and 8. Now, we are asked to find A delta B. Now, for us to find A delta B, it simply means we are looking for the symmetrical difference between set A and set B. Now, how do we calculate our symmetrical difference? We have our set A as minus 5, minus 3, minus 1, 0, 1, 2, and 3. And our set B as minus 4, minus 3, 0, 3, 5, and 8. Now, for us to calculate a symmetrical difference between A and B, all right, that would be A union B minus A intersection B. Finding our A union B would be addition or combination of all the numbers in both sets A and B. Now, for A union B, we have it as minus 5, minus 4, minus 3, minus 1, 0, 1, 2, 3, 5, and 8. And A intersection B would be what's common to both set A and set B. Now, what's common to both set A and set B? We have our first number to be minus 3, 0, and 3. Now, this is what's common to both. So now, if we have A delta B, which is a symmetrical difference, now a symmetrical difference of A delta B is subtracting what is common in both from the union. That would be, we'll be left with minus 5, minus 4, minus 3 is available in their intersection. So we'll eliminate that. Minus 1, 0 is available. So we would eliminate it. So we have 1, 2, 3 is also there. So we would eliminate it. Then 5 and 8. So our A delta B, or the symmetric difference between set A and set B, would be minus 5, minus 4, minus 1, 1, 2, 5, and 8. If A, B, and C are any sets, show that A union B union C equals A union B union C. Now, what this simply means, we should prove that A union B union C equals A union B union C. Now, this is what we look at as our associative law. Okay? Now, first, for us to prove that let's assume let X be our element or any element, all right, for both A, B, C. Now, if X is any element in our set, now for our left-hand side, all right, we have A union B union C, all right? Now, with our element of X, yeah, now this simply means X is an element of A, or X is an element of B, or X is an element of C. Okay? Either ways, X is available in the three of them. Now, for our right-hand side, we have A union B union C, okay, with X also as our element, which gives us X as an element of A, or X as an element of B, or X as an element of C. Now we can see that both conditions are giving us same value, that x is an element of A, or x is an element of B, or x is an element of C. So whichever way it is written, it's been proved that since x is an element of all three sets, all right, now A union B union C, all right, is associative with A union B union C. In an election involving three parties for the chairmanship and gubernatorial elections of Lagos State, voters cast their vote as follows. Now, for Party A, we had 190 votes. So for Party A, we have 190 votes. For Party B, we have 200 votes. Party B, 200 votes. And Party C, we have 250 votes. All right, now 80 voted for A and B. So A and B, A intersection B, we have 80 votes. And for A intersection C, we have 60 votes. And B intersection C, we have 100 votes. Now, for B alone, B only, we have 40 votes. Now, our question says, okay, if 500 people voted during the election, total vote is 500. Now, our question says, find the number of voters who voted for all three parties and the number of voters who voted for Party A and B, but not C. And we have the number of voters who did not vote for any party. All right. Now, that means from our question, we know that there is an intersection between the three parties. We have Party A, Party B, and Party C. Okay, now from here, we are given that the total vote for Party A is 190. Total vote for Party B is 200. And the total vote for Party C is 250. Now, intersection A and B, we have 80. A and C, we have 60. B and C, we have 100. Okay, B only, we have 40. And we have our X as the number of people who voted for the three parties. Now, for us to find the number of people who voted for the three parties, we would have it as, okay, considering Party B, all right, where we have 200 votes. All right, they say 40 people voted for B only. And for us to get B only, we would have a intersection this plus this plus this, 200 minus all we have here to get our 40 only. So B only will give us 40, B only, which is 40. We have it as 40 equals 200 minus, bracket open, 80 plus 100 plus X. Okay, so this will give us 40 equals 200 minus 80 plus 100 will give us 180 plus X. Okay, so 40 equals 200 minus 180 minus x. So 40 equals 200 minus 180 will give us 20 minus x. So therefore, our x equals 40 minus 20. Okay, which will give us x equals 20. So if x equals 20, so if our x equals 20, this would be so if our x equals 20, that means the total number of people that voted for the three parties will be 20. So total number of people, question 1, votes for the three parties, votes for the three parties would be 20 votes. Now, if we have it as 20, our x here is 20 votes. So if we have 20 votes, so for our value for A intersection B would become 80 minus 20, which is 60 votes. All right? Now, so this becomes 80 minus 20, which gives us 60. This gives us 100. A intersection C will be 100 minus 20, which will give us, B intersection C will give us 100. 100 minus 20, which will give us 80. And A intersection C would be 60 minus 20, which will give us 40 votes. So this leaves us with 40 votes. Now, with this, we can find out for A and C only. So for A only, we have it as 190 minus 60 plus 40 plus 20. So this gives us 190 minus 100 plus 20 will be 120. 120. So 90 minus 120 will give us 70 votes. So for A only, we have 70 votes. And for C only, we have 250 minus 40 plus 20 plus 80. Okay, this gives us 250 minus 140, which leaves us with 110 votes. So we have 110 votes for C only. Now, our next question says the number of votes for A and B but not C. So our A and B but not C, which is this, A intersection B, A and B but not C would be 60 votes only. All right, now to the third question that says the number of voters that did not vote for the party. All right, number of voters that didn't vote for the party, we would have it as our total number of votes, which is 500. 500 equals the summation of all these numbers. Okay, so those that didn't vote for the party, let's call it Y. So summation of all these numbers plus Y. So we have 70 plus 60 plus 40 plus 20 plus 80 plus 40 plus 110 plus Y. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, adding this up, we have 500 equals to 100, 200, 310, 350, and 350 plus 70, we have it as 420. So this becomes 420 plus Y. Okay, so Y would be 500 minus 420. So the number of people that didn't vote will be 500 minus 420, which will be 80 people. So we have 80 people who didn't cast their vote. Our next question says, evaluate the determinant A. Now, if we are to find the determinant of A, we have A, and matrix A equals 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now, for us to find the determinant of this matrix, this is a 3 by 3 matrix, we will simply, let's extend this as 1, 2, 4, 5, and 7, 8. Now, for it to be easy for us to find our determinant, in order to do this, we'll multiply this. This becomes 1 times 5 times 9 plus multiply this 2 times 6 times 7 plus multiply this 3 times 4 times 8. All right. Now, minus multiply this 7 times 5 times 3 minus the next one 8 times 6 times 1 minus 9 times 4 times 2. All right. Now, having done this, 9 times 5 will give us 45 plus 7 times 6 times 2 would give us 84 plus 12 times 8 would give us 96 minus 21 times 5 will have 105 minus 8 times 6 48 minus 9 times 8 72. So if we add this all up, we have 45 plus 84 plus 96, which gives us 225 minus, we have 105 plus 48 plus 72, which gives us 225. So our determinant for our A will be 0. So we found the determinant of this matrix to be 0. Now, our next question says, what do you conclude from 2AI above? So from the determinant we've calculated from here, what conclusion can we draw from there? Now, since our determinant is 0, it means that our matrix A, our conclusion is that our matrix A is singular. Now, since the determinant is 0, the matrix is 1, is singular. All right. Now, since the determinant is 0, the matrix is singular. 2, we can also say that the rows and columns are linearly dependent. And 3, we can say that the matrix has no inverse. No inverse. All right. So from here, we can conclude that our matrix A is a singular matrix. Now, the rows and columns are linearly dependent, and the matrix has no inverse. Resolve x cubed minus 1 all over x plus 3 x plus 1 all squared in partial fraction. Hence, obtain its binomial expansion up to times x squared. Now, from here, we would expand this to have it as a over x plus 3 plus b over x plus 1 plus c over x plus 1 all squared. Okay, so from here, in order to equate this, we'll multiply both sides by our denominator. So we say multiply both sides by x plus 3, x plus 1 all squared. So this would be x cubed minus 1 equals, here we have a bracket x plus 1 all squared plus b bracket x plus 3, x plus 1 plus c bracket x plus 3. Now we are going to expand each and every of this term. So for a term, we have it as x plus 1 all squared, which if we should open up will be x plus 1, x plus 1. So which will give us x squared plus x plus x plus 1, which we have as a bracket x plus x squared plus 2x plus 1. Okay, so for our b term, we have it as b bracket x plus 3, x plus 1, which one would expand, we have it as x plus 3, x plus 1, which gives us x squared plus 3x plus x plus 3, which would have at b bracket x squared plus 4x plus. So for our c term, we have it as c bracket x plus 3. So expanding this, we have it still as c bracket x plus 3. Now, we'll bring our three terms together. Bringing our three terms together, we have it as s cubed minus 1 equals a x squared plus 2ax plus a plus bx squared plus 4bx plus 3b plus cx plus 3c. All right, now we would collect our squares together, or let's factorize. Factorizing it, we have it as s cubed minus 1 equals a plus b x squared plus 2a plus plus 4b plus 2a plus 4b plus c x. So this x, factors of x, and plus we have a plus 3b plus 3c, okay, as a constant. Now, from here, on our left-hand side, we know that our x cubed, all right, from here we have x cubed plus x squared, which is 0, plus x, which is 0, plus, minus 1, which is a constant, equals a plus b x squared plus 2a plus 4b plus c x plus a plus 3b plus 3c. So from here, equating this, there's no x cubed here, so we have a plus b x squared equals 0x squared. So that means we can say for our x squared, we have it as a plus b equals 0. Now, let's call this equation 1. Now, for our x, we have it as 2a plus 4b plus c equals 0. And this is equation 2. And for our constant, we have it as a plus 3b plus 3c equals minus 1. So call this equation 3. Okay, so from equation 1, we have a plus b equals 0. So therefore, our a equals minus b. Okay, so if a equals minus b, we will substitute into equation 2. So substituting a equals minus b into equation 2, we have it as 2 bracket minus b plus 4b plus c equals 0. This gives us minus 2b plus 4b plus c equals 0. So we are left with 2b plus c equals 0 and c equals minus 2b. Now substituting c equals minus 2b into equation 3, we have it as a as minus b minus b plus 3b plus 3 bracket minus 2b equals minus 1. Okay, this from equation 3. Okay, and this from equation 2. All right, so now here we have it as minus b plus 3b minus 6b equals minus 1. So minus b plus 3, minus 1 plus 3 will give us a minus a 2, 2b minus 6b equals minus 1. So our minus 4b equals minus 1. So b equals minus 1 over minus 4, which leaves us with 1 over 4. So if our b is 1 over 4, we know that a, which is minus b, would be minus 1 over 4, and c, which is minus 2b, would be minus 2 times 1 over 4, which leaves us with minus 1 over 2. So our ABC will be minus 1 over 4. So back to our equation, recall that we have it as x cubed minus 1 all over x plus 3 x plus 1 all squared equals a over x plus 3 plus b over x plus 1 plus c over x plus 1 all squared. Now, imputing our values for a, we would have it as minus 1 over 4 bracket x plus 3 plus b, which is 1 over 4 bracket x plus 1 minus 1 over 2 bracket x plus 1 all squared. So with this, we've resolved our partial fraction. Now, to obtain its binomial expansion up to times x, we have to expand these terms 1, 2, 3 times in binomial series. Now, for our first term, we have it as minus 1 over 4 x plus 3. Okay. We have our first term as minus 1 over 4 bracket x plus 3. Now, if we expand it in binomial terms, what we'll have would be minus 1 over 12 plus x over 36 minus x squared over 108. Now, for our second term, we have 1 over 4 x plus 1. If we should expand it, we will be having 1 over 4 plus minus x over 4 plus x squared over 4. And for our third term, where we have minus 1 over 2 bracket x plus 1 squared, if we should expand it, we would be having minus 1 over 2 plus x plus, minus 3x squared over 2. All right, now with this, we have both coefficients of x squared, x, and our constant. So for our constant, adding our constants, for constants, we have minus 1 over 12 plus 1 over 4 minus 1 over 2. So adding it all up, our LCM here will be 12. This we would have as minus 1 plus 3 minus 6, which leaves us with minus 4 over 12, which will be 1 over minus 1 over 3. Now for our coefficient of x, we have it as 1 over 36 minus 1 over 4 plus 1 over 1. Our LCM here will be 36, which leaves us with 1 minus 9 plus 36, which would give us 1 minus 9 plus 36 would give us 28 over 36. So if we break it down, by 4, we'll have 7 over 9. And for our coefficient of x squared, for coefficient of x squared, we have it as 1 over minus 1 over 108 plus 1 over 4 minus 3 over 2, which our LCM here will be 108. Okay, this will give us minus 1 plus 108 divided by 4 would give us 27 minus 108 divided by 2 times 3. So this will give us 54 times 3 will give us 162. So this we would have as minus 1 plus 27 minus 162 would give us minus 136 over 108, which if we should break down, will give us minus 34, and 108 divided by will give us 27. So we have this as minus 34 over 27. Now, bringing it back into our equation, bringing them all together, our binomial expansion will now be minus 1 over 3 plus 7x over 9 minus 34x squared over 27 plus dot 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 dot. Now, we've expanded it to the second term of x squared. We've come to the end of today's tutorial. Thanks for watching. See you in the next class.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Kakao, NEET, IALT, and the likes like that. Also, in every video you watch, we have the link to our apps where you can download on Google Play Store and Apple Play Store and practice hundreds of past questions for free.